Circular permutation. Here I have four objects placed around a circle. One thing to note, for objects placed around a circle, cyclic permutations are equivalent, which means that if I take the same arrangement and make a rotation by 90 degrees, these two are considered to be same. And even the other two angles, which is 180 and 270, even these are same. If we had general four objects, directly we could have written four factorial permutations, and these could have been the arrangements. And because cyclic permutations are equivalent, we see that in the first row, the first arrangement has been rotated and therefore they are equivalent. The same with the second row, and so on. Because we have four objects, there are four possible rotations. So these repeated things have to be eliminated. Therefore, we're going to divide it with 4, which becomes 3 factorial, which is 6 arrangements. So whichever has been repeated, let's eliminate them. And the leftover one, these are the distinct arrangements. Let's generalize this. Circular permutation of n objects. Here n objects are placed around a circle, and for n objects, they have n cyclic rotations. Therefore, the number of circular permutations of n objects is, for n objects, there will be fact permutations, so n factorial. From that, whichever are repeating will eliminate, which becomes n. This is n minus 1 factorial. Here we have a question. Find the number m of ways that 7 people can arrange themselves. A. In a row of chairs. B is around a circular table. For the first bit, for people sitting in a row, the number of permutations will be n factorial. Here we have 7 people, therefore n is 7, which becomes 7 factorial. And the B bit is around a circular table. The number of arrangements around a circle is n minus 1 factorial. Therefore, the answer is 6 factorial. Here we have one important thing to note. We have seen that for 4 objects, we have 6 possible circular permutations. And if you carefully observe, half of the arrangements are exactly the mirror images of the other. Here, one important thing to note. If you look at the first one, we have green, red, blue, and violet in clockwise. Here it is green, violet, blue, and red, which is the anti-clockwise of the same thing. So in the question, if they say if the clockwise and anti-clockwise are considered same, then what we do is we discard half of the set by dividing the number of permutations by 2, which becomes 3. We can generalize this as, in circular permutations, if clockwise and anti-clockwise arrangements are considered same, then the number of permutations will be n minus 1 factorial divided by 2. And this formula can be applied for flowers arranged in a garland, or beads in a necklace, or people sitting in a giant wheel. Because for these cases, clockwise and anti-clockwise are considered to be same.